Hi, Eira. I found this conductivity sensor and its probe. All right, this is a 10x probe and this is a 10x sensor. If you want to use this, you would have to bring a sizable sample of the lake water home because, of course, this doesn't have a working battery. It needs to be plugged in. And maybe if you take an empty plastic water bottle, dry it out by just air drying, and then you can fill that with lake water sample. And if you want several samples, you could do that with several water bottles. It's good to get a water bottle full of sample because for conductivity, if you just have a tiny vial of sample, your measurement is going to be ruined by anything that was in the vial, any speck of dust that had salt on it, or anything, any contamination. The turbidity measurement is not as sensitive. It's just a visible light. The measurement is based on visible light passing through the vial, but conductivity, I think it's a bit more finicky, so you would need a sizable sample to eliminate at least some of the error. Now I'm going to put this probe into some dirty turtle tank water that I have here, because there's a turtle here and his tank is kind of green because he likes to eat veggies and he only eats them if they're in the water. All right, so here you could see that I have a reading here. It's 732 microsiemens per centimeter. Now, there are 3 buttons on the sensor, and they are for a range. So if you have a very low range of conductivity, you do this one. Middle range, this one. High range, this one. If I select the wrong range, usually the sensor blinks at what I should select, right? So let me just try to select the wrong range. Well, the sensor is not blinking, but anyways, I guess it might not matter which range you select. I suggest you use the middle. The high range is for ocean water samples. The low range is for drinking water samples, and the mid range is for something in between. And I guess with the lake, you probably have something in between. The conductivity of the water is an indication of how much dissolved ions there are in there, and there is a range that would be healthy for certain species of fish. I kind of doubt that it's the same range for catfish and for bass, even though they have both species in the lake. But I don't have an experience taking care of catfish and bass. But you could use this if you like. There is a way to calibrate this, but it is a bit involved. You have to get some distilled water, and you have to get some salt, and you have to dissolve a certain amount of salt in that water. And I'm not sure how to tell this device that you want to calibrate. I don't think there is a way to tell this device that you want to calibrate. So I suggest the following. Do not just take a reading of the lake water. You must take a reading of the lake water and compare it to something that you know. So for example, drinking water. If you know that if you buy, let's say, Evian drinking water, and then you ask the Google, what is the conductivity in microsiemens per centimeter of Evian drinking water? And they will tell you, then you can calibrate yourself. Instead of calibrating the machine, you can calibrate the human. So if the conductivity of Evian drinking water is X, and then your conductivity of the lake is Y, then the lake has Y divided by X times more conductivity than Evian drinking water, right? So you wouldn't just use this raw number because it's uncalibrated. You would take this number and divide it by whatever this machine says the drinking water is, right? And then the quotient will be a number that you write down, and you will use that as a multiplier. You will multiply the quotient of this divided by what this says for the drinking water. When you multiply that number by what the actual conductivity of the drinking water according to the manufacturer is. You know what I mean? That will give you a calibrated measurement of the conductivity of the lake without actually relying on this machine to do the calibration. I'll include this conductivity sensor and the probe along with the machine along with a turbidimeter and in this gray bag, and I'll leave it with Mark. Bye.